This job aid is designed to help you describe rock and other fragments in the soil using NCSS guidelines and determine the quantity by volume and weight. After viewing this video, you should be able to follow the National Cooperative Soil Survey methods to independently describe and collect rock, pararock, and other fragments in the soil and determine the quantity on a whole soil basis. Before you get started in the field, take time to review the particle size and slaking sections of the Soil Survey Field and Laboratory Methods Manual, Soil Survey Investigations Report Number 51, Version 2, issued in 2014. The rock and other fragment sections of the Field Book for Describing and Sampling Soils, Version 3, issued in 2012. The Fragments in the Soil and Artifacts section of Part 618 of the National Soil Survey Handbook, which you can find at the eDirective website. Summaries of the methods are provided along with any interfering conditions and safety considerations. Also note the equipment list, detailed procedure, definition of equation variables, and how to report fragments. Fragments are unattached cemented pieces of bedrock, bedrock-like material, duranodes, concretions, nodules, or pedogenic horizons like petrocalcic fragments, 2 mm or larger in diameter, and unprocessed woody material that's 20 mm or larger in diameter. Fragments are separated into rock fragments, pararock fragments, which are distinguished by cementation class, wood fragments, and artifacts. It's necessary to know the amount of rock and other fragments for several applications. Available water capacity, cation exchange capacity, saturated hydraulic conductivity, structure, and porosity are affected by the volume, composition, and size distribution of rock fragments in the soil. Fragments also affect the management of the soil and are used as interpretation and classification criteria like particle size and substitute classes. Terms related to volume, size, and hardness of fragments are used as texture modifier terms. Because of this, it is essential to collect a quality sample of proper size prior to submitting it to your lab. Rock fragments are generally sieved and excluded from most chemical, physical, and mineralogical analysis. Exceptions include, but are not limited to, samples containing coarse fragments with carbonate or gypsum indurated material from CR soil horizons and R layers. Rock fragments are further defined as strongly cemented or more resistant to rupture. The rupture-resistant classes are found in the Field Book for Describing and Sampling Soils, page 2-63. Pararock is used if fragments are soft. Pararock fragments are less cemented than the strongly cemented class and do not slake if submerged under water for more than an hour. Pararock fragments are broken into particles 2 mm or less in diameter during the preparation of samples for particle size analysis in the laboratory. The words rock and pararock are used here in the broad sense and do not connote only natural fragments of the geologic material.
The volume of fragments is estimated in a soil sample by sieving through various sieves. We got a 75 mm 3-inch sieve and a 20 mm sieve. The fractions are collected on each sieve. They're set aside to use as a visual estimate. There's a percentage chart in the Field Book for Describing and Sampling Soils under the Miscellaneous tab, and it gives different percentages broken apart visually, so you can use that as a reference for estimating the amount of frag in your sample. We have a sample that has been collected here that has rock fragments in it. We use a 5-gallon bucket with various size sieves on that. The rock fragments are put through the sieve. If it passes in any direction through the sieve, then it's considered passing the sieve. Anything that does not pass the sieve then would be considered that size fraction. Like, for example, this one here, it doesn't pass this way, but it does pass through the other direction. So this would be part of the next size fraction down, which would be the 20 mm sieve. Like I said, the sample is sieved through both a 75 and 25 mm sieve. The fractions are collected and set aside, used for estimating. The portion that passes through the 20 mm sieve is then collected and sent in as your bulk sample to the laboratory. Now that the sample's been sieved, you can estimate the fraction or the volume fractions that you have. So we have the 75 millimeter here, greater than 75 here, then the 20 to 75 here, and then the less than 20 still in our bucket. It looks approximately about 60% of the bucket is less than 20, and then we'll estimate the volume of the other two fractions based upon the volume of the bucket. Looks like we have about 60% here, and I'm going to guess 30 and 10 of the other two fractions.
For horizons that are more than one size class evident, follow the guidelines provided for texture modifiers found in the National Soil Survey Handbook, the Field Book for Describing and Sampling Soils, and other official references to determine the appropriate textural modifier.
Now we need to describe our fragments, and the first thing we need to describe is the kind of fragments we have. These are limestone fragments. The next thing we'll need to describe is roundness. So these will be subangular. Then we also need to describe the hardness, and for hardness, the defining line between pararock and rock is anything more than strongly cemented will be rock. Anything less will be pararock. Then we also need to describe the shape, if they're flat or if they're round. And then we also need to describe the size. When we describe the size of fragments in the field, we use different categories to describe them. You would not want to describe any fragment in the field that is bigger than 10 meters square or bigger than a pedon. Here we have different size classes of fragments. If we're describing non-flat fragments, we have gravel, cobbles, and stones. If we're describing flat fragments, we have channers and flagstones.
The size of fragments is significant to the use and management of the soil. It affects equipment use, excavation, construction, and recreational uses. Fragment sizes are also used as criterion in naming map units. How big of a fragment should be recorded? The upper limit isn't defined, but for practical purposes, it is generally no larger than a pendant up to 10 meters square.
While volume estimates may be fine for some documentation, for laboratory sampling, we need weights of each fraction for the whole soil. And the way we do that is you just take a field scale and you're gonna go ahead and tear out an empty bucket and go ahead and then weigh the whole soil, and then you're going to weigh each fraction separately.
The greater than 2 millimeter fractions are determined by weighings in the field with a 100-pound capacity scale. If your scale has a lower capacity, consider doing multiple weighings to ensure adequate sample size. The fractions determined include the greater than 75 millimeter, 20 to 75 millimeter, and lesser than 20 millimeters. Weigh excavated sample in a bucket of a known weight or tare. Sieve the sample through both a 75 millimeter and 20 millimeter sieve onto a canvas tarp that can be suspended from a scale. Estimate the coarse fragment volume percent of both the 75 to 250 millimeter fraction and the greater than 250 millimeter fraction, and record these values in the description or the sampling notes. Weigh the 20 to 75 millimeter and the lesser than 20 millimeter fractions in pounds or kilograms, and record these weights. Weights are calculated to an oven-dry base in the laboratory. Place a minimum of 4 kilogram sample in a plastic bag, double fold the bag and staple. The water content is determined on the sample in the laboratory. If the 20 to 75 millimeter fraction is not weighed in the field, estimate the volume percent and record in the sampling notes or description. For wood fragments in organic soils or as artifacts, we estimate and record the volume of 20 millimeter and larger fragments. Treated and untreated wood products like lumber are not associated with wood fragments such as tree branches in organic soils, but instead are recorded as artifacts. Woody texture modifiers can be used for any material that contains 15% or more wood fragments larger than 2 centimeters in size, or organic soil materials other than SPM, MPM, or HPM that contain 15% or more fibers that can be identified as wood origin and contain more wood fibers than any other kind of fiber. Artifacts are objects or materials created or modified by humans, usually for a practical purpose in habitation, manufacturing, excavation, or construction activities. Examples of artifacts include bitumen, brick, concrete, metal, paper, plastic, rubber, and wood products. Artifacts are commonly referred to as discrete artifacts if they are 2 millimeters or larger in diameter and are not compacted in a root-limiting layer that impedes root growth or water movement. The amount and type of particulate artifacts can contribute substantially to various trace metals and the total carbon contents of the soils. Discrete artifacts, which are both cohesive and persistent, are treated in a similar manner as rock fragments when populating the standard sieves or in calculations involving sieve entries. Discrete artifacts, which are non-cohesive, non-persistent, or both, are treated as pararock fragments and are not considered fragments for sieve entries or calculations involving those entries. There are some differences to note when describing artifacts. Be sure to describe by cohesion, or the relative ability of the artifact to remain intact after significant disturbance, kind or type of object, penetrability, the relative ease which the roots can penetrate the artifact and potentially extract any stored moisture, nutrients, or toxic elements. Persistence, the relative ability of solid artifacts to withstand weathering and decay over time. Roundness, the sharpness of edges and the corners of objects. Safety, the degree of risk to humans from contact with soils that contain artifacts. Physical contact with soils containing dangerous or harmful artifacts should be avoided unless proper training and protective clothing is available. The risk is based on toxicity to living organisms and not the physical risk that may be present from sharp or heavy objects. Harmful toxicity may be immediate or long-term, or through direct or indirect contact. Examples of innocuous artifacts include brick, concrete, glass, plastic, unprinted paper, and cardboard and untreated wood. Some examples of noxious artifacts are batteries, bitumen, fly ash, garbage, paper printed with metallic ink, and wood treated with arsenic. Some soil horizons contain combinations of artifacts and rock fragments. See Part 618 of the National Soil Survey Handbook for guidance in assigning either single, which is artifact only, compound, which is artifact and rock fragment, or dual, rock fragments and artifact texture modifiers for horizons containing artifacts. The fraction of soil greater than 75 millimeters in diameter is not included in the engineering classification systems. However, it can be added as a descriptive term to the group name, for example, poorly graded gravel with silt, sand, cobbles, and boulders. Estimates of the percent of cobbles and boulders are presented in the soil descriptions for a group name. A small amount of these larger fragments generally has little effect on the soil properties. The fragments may have an effect on the use of the soil in certain types of construction. Often, the larger portions of soil must be removed before the material can be spread into thin layers, graded, or compacted and graded to a smooth surface. As the quality of this oversized fraction increases, the properties of the soil can be affected. If the larger particles are in contact with each other, the strength of the soil is very high and the compressibility very low. If voids exist between the larger particles, the soil will likely have a high saturated hydraulic conductivity and may undergo some internal erosion as a result of the movement of water through the voids. Most of the smaller and more rapid construction equipment normally used in excavation and earth moving cannot be used if the oversized fraction of the soil is significant. This job aid is designed to help you describe rock and other fragments in the soil using NCSS guidelines and determine the quantity by volume and weight. An experienced soil scientist can help you develop your technique for describing fragments and proper sampling. As with any new skill, proficiency comes with practice. For more information and tips on sampling soils, please see our online NCSS training materials.